That's why we have to apply this really cool identity, trigonometric identity. So okay, let's do some math for fun. Today we are going to integrate inverse cosine of x over x squared plus 1 dx from -1 to 1. And as always, if you guys interested in this video, pause the video and try them for yourself. Well, I hope you guys try this question, and if you guys really try this question, I hope you get the same answer as me, which is equal to pi square over 4. I hope you guys also get this same result. So if you ask me how to do this now, well, now look at it. Now look at this integral. Now inverse cosine of x, we can integrate inverse cosine of x using integration by parts. But if you want to use integration by parts to integrate inverse cosine of x, we should differentiate the inverse cosine of x. But at the same time, 1 over x squared plus 1 we can differentiate, but in the same time we also can integrate 1 over x squared plus 1, right? So to do integration by parts, let me just do some data trick. So I will write the differential column and the integral column right here, and I will put some plus minus, and I will let the differential column be the inverse cosine of x, and the integral column will be 1 over x squared plus 1. And I hope you guys are really used to this kinds of situation, because we can just do this in our mind. Now the derivative of inverse cosine of x is equal to -1 over the square root of 1 minus x squared, while the integral of 1 over x squared plus 1, that's nicely equal to inverse tangent of x. So what are we going to do is inverse cosine of x will be multiplied to here, so we will get inverse cosine of x times inverse tangent of x. From where to where? From -1 to 1. And then what we are going to do is we're going to integrate the product of a row. So what we're going to do is we're going to minus times minus, that's plus. So we will plus the integral, since we got the limit, we will just write -1 to 1 of inverse tangent of x over square root of 1 minus x squared dx. And look at what we got here. Now inverse tangent of x, remember, inverse tangent of x is an odd function. So if you guys know what is odd function, basically odd function is basically the function that satisfies the property of f of negative x is equal to negative times f of x. If f of negative x is equal to f of x, then it is called the even function. So even function is equal to, so okay, not equal to, where it's not equal to. So the even function is a function that satisfies the property f of negative x is equal to f of x. So now we will identify the property. We will identify whether this function is either an odd or even function. Why? Because we got the limit. We got the limit. If we have the limit, we will concern about whether the function is an odd or even, because when you have the integral from negative a to a of odd function is going to be equal to 0. If it's even, let me scroll this down first. If it's the integral from negative a to a of even of x dx, well, this represents even and odd function, which is equal to the twice of the area of even function of x dx from 0 to a. So that's the rule. So what we're going to do is we are going to identify whether this function is a odd function or even function. Now look at this. Now inverse tangent of x. If it is now inverse tangent of x, it satisfies the odd function property, which means that inverse tangent of x is an odd function. While 1 over square root of 1 minus x squared, it satisfies the property of even function. So we can say that 1 over square root of 1 minus x squared is going to be an even function. And when an odd function times an even function, that's going to result in an odd function. So what we can say is this whole thing is nicely equal to 0. It's just basically a decoration. So what we can is to focus at here. Now inverse cosine of 1. What is the value of inverse cosine of 1? Inverse cosine of 1. Okay. So let me just draw this down right here. And let me just bump the paper. Inverse cosine of 1, this is going to be 0. So 0 times inverse tangent of 1, that's still going to be 0. So this whole thing is equal to 0 minus the inverse cosine, well, actually wrong color, minus the inverse cosine of negative 1 times inverse tangent of negative 1. So what we can see here is inverse cosine of 1 is nicely equal to pi, and inverse tangent of negative 1, we know that this is actually the angle at the what is it, at the, we know that inverse tangent of negative 1 is going to be the angle at second quarter and the fourth quarter, but we don't consider that because we know the inverse tangent of x is an odd function. So we will use the property of odd function. So inverse tangent of x, inverse tangent of negative 1 is going to be equal to negative times inverse tangent of 1, which will result pi over 4. So we got negative, and you need to multiply that negative 1 inverse cosine of negative 1. Now remember, inverse cosine is not odd and not even. They are neither, because they are neither. So inverse cosine of negative 1 is going to be equal to pi, and inverse tangent of 1, because I already plucked out the negative 1, it's going to be pi over 4. So negative times pi over 4, which will result pi square over 4, and this is the beautiful answer for this integral. Okay, now let me show you guys the second method to solve this integral without using integration by parts. Now, well, instead of using integration by parts, we will use some trigonometric identity. So what is a trigonometric identity that we will use in this integral? Now remember what I wrote of the properties of odd and even function. Now, since you guys already know what is this about, so we can actually determine whether this function is an odd or even function in the first place. But does it really an odd or even function? Now, 1 over x squared plus 1 is an even function. But does inverse cosine of x is an odd function or is it an even function? Well, neither. They are not both. They are neither odd nor even function. So that's why we have to apply this really cool identity, trigonometric identity. So that is inverse sine of x plus the inverse cosine of x is equal to pi over 2. That is a very nice trigonometric identity. Okay, now so this is what you might ask me, why this identity could solve this integral. Well, that's because if we let inverse cosine of x as subject formula, then we get inverse cosine of x is equal to pi over 2 minus inverse sine of x. And if we plug this in, then we will get the integral from -1 to 1 of pi over 2 minus inverse sine of x over x squared plus 1 dx, which is equal to pi over 2 times the integral from -1 to 1 of 1 over x squared plus 1 dx minus the integral from -1 to 1 of inverse sine of x over x squared plus 1 dx. Now, here's the key. Now, okay, we know that inverse cosine of x is neither odd nor even. But what I can see is inverse sine of x, that's an odd function. And pi over 2 is a constant function. And remember, constant function is always going to be an even function. So what we can see is since inverse sine of x is an odd function and 1 over x squared plus 1, that's even function. So odd function times an even function, that's odd. So remember, the integral of odd function from -a to a dx is equal to 0 for all real values of a. So what we can say is this thing is nicely equal to 0. So we can just concentrate this. So we can just concentrate this part. Now, what now? The integral of 1 over x squared plus 1 dx, well, you know, it's obvious. Which is going to be equal to pi over 2 times inverse tangent of x from -1 to 1. So what we can say, which is equal to pi over 2 times inverse tangent of 1 minus inverse tangent of -1. Now, inverse tangent of -1 right here, which is equal to negative times inverse tangent of 1. So what we get is this. So we put that minus outside, we get plus, which is nicely equal to pi times inverse tangent of 1, which is equal to pi times pi over 4, which will give us the result pi squared over 4. Very nice, because this, and if you ask me, that this integral is come up by myself, and it is actually a very nice integral, because it not actually works in integration by parts. It also works when we use some special trigonometric identity. Oh my gosh, this is really cool. I hope you guys learned something from in this video, and leave a like if you want me to show more this kind of integral, and comment down below if you want me to have some tutorial about, or you want more information about odd and even function. And as always, I will see you guys next time.